This video is about comparing the first and the second derivative. Let's fill out this chart. The first derivative basically dealing with increasing or decreasing. So when the first derivative is positive, it's an increasing function. When the first derivative less than 0, that means for that interval, the function is decreasing. When the first derivative equal to 0 means not increasing or decreasing. For the second derivative, it's dealing with the concavity. When the second derivative is positive, we know the graph is concave up. When the second derivative is negative, the graph is concave down. When the second derivative equal to 0 means no concavity. When you see increasing, you will draw the graph from left to the right. It will be like this. From lower position to higher position. When the graph is decreasing, which means you need to draw the graph from higher to lower position, like this. Let's draw increasing and concave up. It will be the graph like this. Increasing concave down, the graph will be like this. No concavity means a straight line. If it's decreasing concave up, it will be the graph like this. Decreasing concave down, it will be this way. No concavity means a straight line. We also have the graph is increasing, but the second derivative is 0, means no concavity. It will be the graph like this. And in the middle, when the concavity changes, then this point, we call this is a non-stationary inflection point. For decreasing and no concavity will be this. The point which connect to concavity, the different concavity, we call this is a still non-stationary inflection point, this point. When the first derivative equal to 0 and it's a concave up, you could say it will be the local minimum point here. Local minimum. When the first derivative equal to 0 but is concave down, then you could say it's a maximum point. Like this. It's a local maximum point. The first derivative equal to 0 and the second derivative also equal to 0. It could be the horizontal line or the stationary inflection point like this. these 2 points we call is a stationary inflection point. Let's study more about the second derivative equal to 0. And the second derivative equal to 0, you will find the points called the point of inflection. There are 2 types of point of inflection. One called stationary inflection point. That is the first derivative equal to 0. The other one is non-stationary inflection point. The first derivative not equal to 0. No matter which type of point of inflection, you could say the concavity changes at the POI. Check here, this is a concave down. You see the curve, concave down. Then after the non-stationary inflection point, it changed into concave up. This one, see the concave up, then change into concave down. For stationary inflection point, this is a concave down because you could see the graph will be something like that. Then this part is a concave up because your graph will be something like this. They change at x equals a. See here, this is a concave up, then change into concave down. So how you decide at x equals a, it's an inflection point. First of all, definitely you have to make sure the second derivative equal to 0. And also the concavity changes at x equals a. In other words, the second derivative has a sign change at x equals to a. Now let's practice one question. If the second derivative equal to 0, it's 0, 0, the inflection point. You just need to check the concavity change or not. See for the first one, this is a concave up. You could see, yeah, this is concave up. Then over here is a concave down. This is a concave down. Therefore, yes, this is a inflection point. But check here, for this curve, basically it's a concave up. This curve still is a concave up. Since there is no concavity changes at this 0, 0, therefore it's not an inflection point.